Yes, good morning, friends. How are you all? Today we are going to talk design issues in distributed operating system. So, design of distributed system should be done after addressing the certain issues that affect its version. Distributed system should remain transparent. That is, it should give impression of a uniprocessor to the users of distributed system. System should also be flexible to accept communication, memory management, process and scheduling. Primitive system should be scalable, reliable, and up to mark on performance. Okay, so now let's move to distributed system should abide by the transparency rules. Okay, transparency, there are several types of transparency. First, location. Second, migration. Third, replication. Fourth, concurrency. And fifth, parallelism transparency. Okay. So first, location transparency. User of the system does not need to know where resources are distributed. Second, migration. Resources can be moved between the components of the system without their names being changed. Third, replication transparency. System is free to make multiple copies of files without users being affected in order to provide a guard against failures. Okay. Next, concurrency transparency. Multiple users can share resources automatically in the distributed system. Next, parallel. Activities can happen in parallel without users knowing that some other task on the system is going on simultaneously. So, so friends, here we can show that microkernel and operating system services, user, file server, directory server, and process server. Okay, along with microkernel and network. Next, flexibility. Kernel which interacts with the hardware should do as little as possible. User level servers are primarily responsible for providing bulk of operating system services. So the kernel, which is popular known as the microkernel, is responsible for inter-process communication, some memory management, some low-level process management and scheduling, and low-level input and output. All other services are obtained by sending messages to the appropriate server. Next, advantages. See, modular. First, modular. Modularity is distributed system feature which provides advantage for its users to work independently besides having the advantage of resource sharing. Okay, the modules of the system are interconnected with a high speed network. Next, every client has equally opportunity to access server regardless of location, hence making the system location transparent. These are the advantages. Okay, and earlier we saw that the kernel which is popularly known as the microkernel is responsible for such type of functions. Okay, after flexibility, let's go to reliability. Distributed system should behave in reliable manner for its users. Reliability of the system is confirmed if it satisfies the following things. First, availability. Resources are always available for sharing. Next, protection against unauthorized access and data loss. System applies a mechanism to prevent unauthorized access of data. Cryptography, digital signatures is one of such mechanisms which makes the data unavailable for the unauthorized user. Next, data consistency. If maintaining multiple copies of data which is shared among multiple users of distributed system should be same and consistent. it achieved through concurrent updates. Okay, next, fault tolerance. Some of the fault in system might require great efforts and expenditure. Such kind of faults may be overlooked to certain level. So friends, if we talk about reliability, reliability of the system is confirmed if it satisfies the following: first, availability; second, protection against unauthorized access and data loss; third, data consistency if maintaining multiple copies of data; and fault tolerance. Next, let's go to performance. Our distributed system should not run an application slower than as if it were being run on an independent computer. Okay, so performance of the system is measured in terms of first, response time; second, throughput; third, system utilization; and fourth, network capacity consumed, etc. So if we talk about response time, system responds to demand; throughput, measurement of efficiency; system utilization, system is utilized for optimization; network capacity consumed, network is used in its full capacity. Okay, but performance is affected by communication failures. Okay, next, let's go to scalability. Current distributed systems are designed to work with a few hundred CPUs. Distributed system is scalable if it can still work with thousands of CPUs connected and its performance is not degraded. Centralization and decentralization of distributed system. Implementation of centralized control in distributed system is not possible due to the problem imposed by distributed architecture of the system. So decentralized control is used, that is, all control functions are distributed among various sites of the system. But in distributed system, due to the absence of global shared memory, it is not possible to have up to date knowledge regarding processes and resources, and in the absence of updated global states of distributed system, it is also difficult to implement decentralized control. Next, let's go to scheduling. Another important function of operating system is scheduling, which is mainly done on the basis of arrival time of the processes. But in case of DS, due to the absence of global physical clock, scheduling is also difficult to implement. Next, naming. Okay, so what do you mean by name? A name refers to an object such as computer, printer, file, a service, etc. What? A name refers to an object such as computer, printer, file, a service, etc. One of the services is naming service, which is implemented using lookup procedure. In in table lookup procedure, tables or directories are used which contains the logical name. Such directories can be implemented in two ways: first, replication, and second, partition. A directory is replicated at each side in order to avoid single point of failure, and, and in order to increase the availability of the naming service. Consistency problem, that is, any modification in a directory at one site should also be reflected in same copy at other site. Okay. Second point under naming service, okay, partition. Directory is partitioned into various blocks, and then these blocks are distributed among various sites. This approach also has problem of locating the corresponding block where data is stored. So uh, So this problem can be solved by creating another directory which contains the information regarding location of these blocks, and then this directory is replicated at various sites. So it refers to the concept that when the system grows, then it should not result in the unavailability or system or performance degradation. Right? Next, Compatibility, it refers to interoperability among resources. That is, a resource can be used from any computer or it can be used in combination with other resource. Okay, there are three levels of compatibility: binary, execution, and protocol. Okay, binary level, a system is binary level compatible if all machines are executing same instruction set, that is all of them have same architecture. Most of the operating system functionalities are dependent on underlying machine architecture, and since architecture is same for all machines, so operating system codes will be easy to implement. Next, execution level, a system is having execution level compatibility if the same order can be compiled and executed on any machine of the system. Next, protocol level, a system is having protocol level if all machines are sharing same sets of rules. Okay, what do you mean by protocol? Protocol is set of rules and regulations. Next, process synchronization. See, processes running on different machines must access and share resource in a mutually exclusive manner. In such system, a process can request or release resource at any time and in any order, which may lead to deadlock. Such deadlocks must be detected as early as possible, otherwise system performance will degrade. Okay, so in process synchronization, we will study resource management, data migration, computation migration, and and process synchronization. Okay, so in if we talk about resource management, in such system a user must access the remote resources with as much ease as it can access the local resources. Next, data migration. In this approach, data is transferred from its source to the location of computation, and if any modification is made in the data, then it is also reflected at the source site. Next, computation migration. In this approach, computation itself is migrated to the location where required data is present. Next, process migration. In this approach, the entire process is migrated to the location where data is present. In DS, usually the processes are executed on the sites where they are generated in order to support load sharing. Next, security. Two main aspects of security are authorization and authentication. Authorization. It basically involves assigning access rights to the users regarding resources. Authentication, it involves the checking of access rights of users while accessing a particular resource. And next, structuring. The structuring of distributed operating system can be performed in three ways: monolithic kernel, collective kernel approach, and object oriented kernel. Okay, so if we talk about object oriented kernel, all services of operating system are implemented in the form of objects. Each object encapsulates a data structure and also a set of operation for those data structure. Okay, such as clouds. Okay, if we talk about a collective kernel, operating system is designed as a collection of independent processes where each process represents some service such as distributed scheduling, distributed file system, etc. So the kernel consists of a nucleus of operating system called microkernel, which is installed on all the machines and provides basic functionalities. Next, monolithic kernel. DOS is designed in the form of monolithic kernel where the kernel contains all the services provided by operating system, a copy of whose kernel is running on all the machines of the system. The limitation of this approach is that most of the machines will not require most of the services, but the kernel is still providing it. So friends, if we talk about design issues in distributed operating system. Okay, first of all we have to tell about transparency. First of all, we have to tell about transparency. Next, flexibility. Next, reliability. Next, we need to tell about performance. Next, we have to tell scalability. Next, we have to tell scheduling. Next, we need to tell naming. Okay, under naming we have to tell replication and partition. Okay, next, compatibility. Okay, and inside it we have to tell about binary level, execution level, and protocol level. Okay, here binary level, execution level, and protocol level. Okay, next we have to tell about process synchronization. Okay, inside this topic we have to tell resource management, data migration, computation migration, and process migration. Next, security, authentication and authorization, and last, structuring, about monolithic kernel, a collective kernel approach, object oriented kernel. So friends, these are the design issues in distributed operating system. Okay, I hope you must have got knowledge. Thank you very much.